Hi class again, good morning. So by this time we will now discuss about the effects of increasing the condensing temperature. Okay, so last time, previously, we discussed about the if the temperature of the or the evaporating temperature will increase. Okay, so by this time, if we are going to increase the condensing, not the evaporating, but the condensing temperature. Okay, so let us now investigate this. So what are the parameters that may be affected? Okay? So again, so this is class similar to the problem. So that was previously given. So a simple saturated refrigerating cycle using R12 as the refrigerant operates at the condensing temperature of 40. Take note class, the condensing temperature is 40 and an evaporating temperature of negative 10. So this is similar to the previous example. Show the effects of increasing the condensing temperature to 50. Okay, so we will now class increase the condensing temperature to 50. Excuse me. Okay, so if we now take a look class the pressure enthalpy diagram, so we will notice that 1 and 2 and then 2 prime, 3 prime, 3 and 4, 4 prime. Excuse me. Okay, so here is now class the condition. So at 1 that is negative 10 and then at 2 the condensing temperature is only 50 and then at 2 prime the condensing temperature is 50. Okay, so take note class the difference between the pressure. So at 40 degrees that is 961 and then at 50 degrees that is 1219 kilopascal. Okay? So you can easily determine class or identify whether the enthalpy at the yes of the condensed liquid or refrigerant, of course the enthalpy will increase. Okay, will increase. Okay, so let us now proceed. It's sub 1. So previously determined. So in the previous example, so the value is 347.1 kilojoules. B sub 1. So at negative 10 0.07665. So for 40 degrees condensing cycle, so 1, 2, 3, 4 up to 1 to complete the cycle. It's 1 at 40 to 385.5. It's 2 at 961, 373. Okay, already known. And then for 50, the condensing cycle, so 1, 2 prime, 3 prime, 4 prime to 1. Okay, so take note class that the enthalpy, okay, will increase, okay, if we increase the condensing temperature. So take a look now class. So the value of the enthalpy of liquid is 248.9 as compared to the previous which is 238.5. Okay? So for H sub 2, so at 1219 kilopascal is 1 equals to S2. So the value now is 378 kilojoules per kilogram. Okay? So take note now the refrigerating effect class. So for the refrigerating effect, so at 40 degrees condensing temperature, the refrigerating effect is H1 minus H4. So that is 108.6. Okay? So take note class here. At 50, the value is 98.2. So therefore, in increasing the condensing temperature, the refrigerating effect decreases. So up to 98.2 kilojoules per kilogram. Okay? Next. So, effect on mass flow rate per ton. Okay? So, for 40 degrees condensing, so mass flow rate. So, that is the same formula class. So, the previous. discussion. So M equals to 211 kilojoules per kilogram, where 211 is derived from 3.516 kilowatts per ton multiplied by 60, that is 210.6 something, or 211. So divided by the change in enthalpy, so that is 1.943 kilogram per minute per ton. Okay, so that is at 40. So let us take a look at now at 50. Okay, so the difference is, okay, 211 divided by 2, 347.1 minus 248.9. So that is 2.149 kilogram per minute per ton. So take note, class. So the value at 40 is only 1.943. So it will now increase. So the mass flow rate, okay? So per ton. So that is 2.149. So increase. Next. Effect on compressor volume capacity. Okay, at 40, the same, 0.1489 cubic meter per ton. And at 50, 0.1647. So the value will increase. Okay? So take note, class. All the values except for 50 degrees centigrade are already known. Okay? So the coefficient of performance now. Okay, so at 40, the coefficient of performance is 3.90 or 4.19 rather. But at 50, the coefficient of performance is only 318. Okay? 318. Okay? 3.18. So, meaning the coefficient of performance, once you increase the condensing temperature, will decrease. Okay? So, another is the effect on work per ton of refrigeration. Okay, per ton of refrigeration. Take note, at 40, so M, H sub 2 minus H sub 1. So, the value class is 50.32 kilojoules per minute per ton, or 0.839 kilowatt per ton. But at 50, that is 66.40 kilojoules per minute. So, take note, class, that the value of the effect on work per ton will increase. So, it will become 1.107 kilowatt per ton. Okay? Another is the effect on condenser performance. Okay? At 40, again, QC equals to M, H sub 2 minus H sub 4 or H sub 3. Okay? Take note, the value of H sub 3 is the same as with the value of H sub 4. Okay? So, the computed value now is 261.3 kilojoules per minute per ton, or 4.355 kilowatt per ton. And then at 50, the computed value is 277. Okay? So, it will increase, class, or 4.623 kilowatt per ton. Okay? Okay, class. So, here is now the summary. Effect of increasing the condenser temperature. Okay, 1. The refrigerating effect per unit mass decreases. The mass flow rate per ton increases. The volume flow rate per ton increases. COP decreases. The work per ton increases. And the heat rejected at the condenser per ton increases. Okay? So, thank you very much, class. So, that is the effect when we try to increase the condensing temperature of the system. So, thank you very much, class.